If you're watching this as a video, we're not going to be able to go through some of the activities for this first day one as an example of the Federalist Papers, so we're just going to have to skip over that, and we'll come here into samplings and surveys. So the first thing says, what's the difference between a population and a sample, and this is what's a census. So a population is just, in a statistical study, is the entire group of individuals about which we want information. A sample is a part of the population from which we actually collect information. We use information from a sample to draw conclusions about the entire population. So the population is just your entire group. The sample is a subset. A census is when we collect data on the entire population. Obviously, that's pretty time-consuming. It costs a lot of money. The U.S. only conducts a census every 10 years just because it does take so long. All right, so population, entire group, sample, subset. Go ahead, pause the video, read these two problems right here, and you should be able to answer those two problems. When you're done, unpause the video, and we'll go over it. So for the first one, the population is all the high school students. The second one, and then the sample is just going to be the 100 students that you spoke to. In the second one, the population is all the cans of soda in that hour, and the sample is the 10 cans of soda in every hour. The next one, go ahead and try that one. Pause the video again. Take a second to try that one. Unpause it when you're ready. And this one right here, the population is all households. What was being measured? So they were asking them 5 questions. They were putting them together to combine them as an index, but it's 5 questions that were being measured. And then it says, how is the sample selected? So this question's really not clear. Hopefully it was a random sample because they are talking about it being representative, but that's really all I can tell here about the sample. All right, before we talk about ways to sample well, there's definitely ways to sample poorly. So a convenient sample is one of those ones where we don't sample so well. So a convenient sample is just choosing individuals who are easiest to reach, results in a convenient sample. So if I'm just standing in my room and I ask my class, what do you think about the dress code policy? That's just a convenient sample. It's just easy for me. You're right in front of me. It's just easy for me to ask those questions. The problem with those convenient samples, and the problem with a lot of these things, is that it introduces bias. So bias is going to result in us either consistently overestimating or underestimating the value that we want to know. So again, if I'm trying to figure out what you think about the dress code, you might have a different perspective just because you're an AP class, and so I might. But if I ask you because it's convenient, I might underestimate the opinion of the school. It says here, if you're asked to describe how the design of a study leads to bias, you're expected to identify the direction of the bias. So as an example, suppose you're asked, explain how using a convenient sample of students in your statistics class to estimate the proportion of all high school students who own a graphing calculator could result in bias. So you might respond, this sample would probably include a higher proportion of students with a graphing calculator than in the population at large, because a graphing calculator is required for the statistics class. That is, this method would probably lead to an overestimate of the actual population proportion. So again, if you're just asked to describe how it leads to bias, you're expected to identify the direction. So here it's overestimate. All right, a voluntary response sample. So here's another definition of bias here. So the design of a study is biased if it systematically favors certain outcomes. So again, you're either likely to over or underestimate. All right, a voluntary response sample consists of people who choose themselves by responding to a general appeal. Voluntary response samples show bias because people with strong opinions, often in the same direction, are most likely to respond. So voluntary response is like if you go on the web page and you see a question and you choose to respond to it. People who are choosing to participate generally have a very strong opinion, and most of them share that opinion, so they're definitely going to be biased in one direction. Go ahead and try this one again. Pause the video, unpause it when you're ready to go over it. So for this one right here, again, more than one way to say this, but no. So people choose to respond to this survey. So people who felt strongly probably responded. So people who strongly felt no were more likely to respond. So this likely overestimates the actual population proportion. All right, so those are some ways that we can sample poorly. So how can we sample well? So we can use a simple random sample. So a simple random sample, which will abbreviate SRS. There's something called a stratified random sample, but we don't abbreviate that one SRS. So if you see SRS, it's referring to simple random sample. So it says a simple random sample of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be in the sample actually selected. So how can we select a simple random sample? We can use we just need to use some sort of device to have the randomness. So perhaps we use a dice, or perhaps we use a deck of cards, or we use the calculator. We can also use the random number table, which we're going to use mostly in this class. All right, here's the question here. So let's say I have 24 students in a class. And I want to take a simple random sample of size 4. So if I have, so ideally I could put all those names in a hat. I draw out 4 names, well I shake the hat, draw out 4 names, there's my simple random sample. What if I did it like this though? So what if I had group 1 and there were 4 kids at a table, so here's 4. And I had group 2 and there was 4 kids. And I kept doing this until I had 6 groups. So I've got 24 kids and I've got 4 kids at 6 tables, so there's my 24 kids. And then I say, okay, come on. And those 4 kids. So it's definitely random, but is it considered a simple random sample? So you want to ask yourself, in this scenario right here, does every possible group of size 4 have an equal chance of being chosen? So the answer to that is no. The problem with this one is that when I roll that die, I'm going to take a table and take all the kids. I will never be able to, in this method, get a sample that includes kids from different tables. So not all possible groups of size 4 have an equal chance of being chosen. All right. Like I said, we can use now there was randomness in that scenario. It is called a cluster sample. We'll talk about more about that in the next lesson. So we can use the dice to select a random sample. You can put people's names in a hat to select a random sample. You can use the calculator. We can also use something called a random number table. So I have that right here. The random number table allows us to select a sample, and it allows us to select one in such a manner that everybody's going to get the same answers, so I know that you did it correctly. So the 2 properties of a table of random digits is that each entry in the table is equally likely to be any of 0 through 9, so any of these 10 digits. So when I look at, I just randomly find a spot here, it's this number right here is equally likely to be any value 0 through 9. And the entries are independent of each other. So it's literally like we had infinite numbers of papers with 0 through 9 on them, and we're just drawing them out of a hat and writing down those numbers there. So, and we're replacing them, of course. So just because I have a 2 here, that doesn't tell me any knowledge about the next one. So each number 0 through 9 is equally likely, and each entry, each number is independent of the prior one. So just because whatever happened prior doesn't influence what's going to happen next. If we sample, so with replacement means that we take something out and we put it back in. Without replacement is we take it out and we don't put it back in. I would say the majority of the time we are ending up in this scenario. The reason for that is that if you're trying to select students to be part of a group, once you select a student, you can't select the student again. So we're pretty much sampling without replacement. So how should you account for this? So you need to tell me when you're describing what you're doing if you are going to keep repeats or ignore repeats. And you just have to tell me in both scenarios. When we go through and do these problems, we have 2 steps. So step 1, we label it. So you have to label the people or whatever it is in your sample, or sorry, in your population. I said that wrong. You've got to label your population. You want to make sure you give everything the same length, and ideally you use the smallest label possible. If you can use 1 digit, go ahead and use 1 digit. It's the smallest label possible. It'll just make it go quicker for you. Also, make sure you're telling me what you're going to do with repeats and numbers outside your label. When you're working with a table of random digits, it's very important. So if you're working with a table, it's very important to specify the length and make sure that the labels have the same number of digits. For example, if you need 50 labels, you don't want to use 1 through 50. You want to make sure it's 0, 1 through 50. So everybody has a 2-digit label. The single digit 1 has a 10% chance of occurring, but the 2-digit combination has a 1%. So you want to make sure you're labeling everybody with the same length of digit, so the likelihood of finding those digits is the same. When we're using the table, we're going to read consecutive groups of digits of the appropriate length from table D. So if you're doing 2 digits, you're going in 2-digit chunks. Don't overlap your chunks. Your sample contains the individuals whose labels you find. If you reach the end of the row, continue to the next row. So this one right here, the management company of a local mall plans to survey a random sample of 3 stores to determine the hours they would like to stay open during the holiday season. So use a random digit table at line 101 to select a simple random sample of size 3 stores. Note these are labeled for you. So the labeling part's already been done. This is just more practice with using a table. The problem will need to tell you where to start. So if I go here, line 101, again, these are all 2-digit labels. So I'm looking at 2-digit chunks. I'm going to write down the 2-digit chunks. You don't have to do this. I just want you to see. So the first one I come across is 19. I do have a store 19. The next chunk I came across is 22. I don't have a store 22. This 3 here from this line, this chunk, I'm gonna have to join it with that 9 to get a 2-digit chunk. I do not have a store 39. Then I have 50. I do not have a store 50. 34. I do not have a store 34. 05. I do have a store 05. After 05, I have 75. No store. 62. No store. 87. No store. 13, I have a store. So I can stop there. I just need to select 3 stores. So we've got stores 05, 13, and 19 are selected. All right, the next problem says there's 29 students in my period 1 class. That's my population. I want to randomly select 5 students. So 5 are going to be my sample. To form a group, use line 121. So this part A here, we didn't have to do up here. So describe how you will label and select the 5 students. Make these instructions clear enough so someone can carry out your procedure. I've got 29 students. I'm going to have to use a 2-digit label. So the students will be labeled 01 through 29. I will look for 2 digits within my range, inclusive. When I say inclusive, I mean, so I'm looking for numbers within this range, including 0, 1, and 29. And ignore repeats. So once I select a student, I cannot select that student again. Again, give each member of the population a label. State what you're going to do with repeats and numbers outside your labels. So again, you can write, there's a couple other ways you could write this. You'll see some of my examples I'll write it a little differently. So I'll look for 2 digits within my range, inclusive, ignore repeats. I could say I will look for 2 digits. If they're outside my range or a repeat, I'll ignore it. So you could write those a little bit differently. This tells me here to use line 121. I'll just mark up my chart here. So 71, I don't have a 71. 48, I don't have a 48 student. 70, I don't have a 70. 99, I don't have one. 84, no. 29, I do have a student, 29. So 29 is going to be the first student selected. I do have a student, 07. So 07 will be my second student selected. 71, no. 48, no. 63, no. 61, no. 68, no. 34, no. 70, no. 52, no. 62, no. 22, I do have a student 22 in that range. 45, no. 10, yes. 25, yes. Again, if you needed to, if you went to the end of the row, go to the beginning of the next row. All right, you can pause the video and try then one at the top of the next page. When you're ready, unpause the video. All right, the smallest label possible here is 1-digit label. Again, it's not wrong to do 2 digits, it's just that it's going to take you longer. So the smallest is to use 0 through 9 because there's 10 values there. So I will label the students 0 through 9. I will look for 1-digit inclusive and ignore repeats, 1-digit inclusive of my labels, and ignore repeats. The first 5 will go in group 1, the remaining will go in group 2. I went to line 146, I got 3, 7, 6, 0, 9. Everybody else automatically goes in group 2. If you did it with the 2-digit label, depending on how you labeled it, because you might have done 0, you probably did 0, 0 through 99, no, 0, 0, well, you could have done 0, 0 through 10, or you could have done 0, 1, no, 0, 0 through 0, 9, sorry, or you could have done 0, 0 through 10. Nope, 0, 1 through 10. Let's try that again. If you did a 2-digit label, 0, 0 through 0, 9, or you could have done 0, 1 through 10. Depending on how you approached it, your answers might be a little bit different. All right, again, we can use technology. I'm going to show you the command down here, but you would get different answers from me and others, so it makes it difficult for AP readers and myself to grade. Typically what happens on the AP test as well as on my test, instead of giving you a table, they just give you a chunk of the table and you use that chunk to answer the question. All right, down here, so on the older calculators, we just had RandInt, and that could give you repeats. So on the older calculators, you would go to the math button, which is below the alpha, over to PROB, hold on, I don't want this. I don't know, my screen just went to sleep. And I don't want you to see the sleep. I don't know if you were or not. All right, so with the older calculators, we only had option 5 here. So if we were trying to do the problem from up above, 0, 9, and we wanted 5 students, the problem is what can happen is that we can get repeats. So then you might need to maybe generate another student to replace the repeat, or maybe you run the command again. The command always works. Again, it's math, PROB. So that random one, it's your lower label, your upper label, and then how many you want. Like I said, the problem with this one is that we can get repeats. To the newer calculators, we go to math, PROB, we go to random, no repeat, and then this one ensures we don't get any repeats. So I get no repeats in that group. So you could do it that way. Sometimes I've explained this before, but the calculator has an algorithm to generate random samples. So sometimes we have to trick the calculator into starting. If everybody came in the room and you all cleared the RAM on your calculator and we ran that command that we just ran, you would all get the same sample because the algorithm is starting at the same point because we just cleared all the RAM. So sometimes in class, I might tell you to reseed the calculator. When we seed the calculator, we'd go to math, you type in a number, any 4-digit number or 3-digit, whatever, you go to math, PROB, that's still not going to work. You type in the number, you hit store, which is above the on, then we go to math, PROB, number 1. So it just stores the number, so then it just ensures that I get a different algorithm. Again, don't worry about that unless I am telling you that we need to reseed the calculator, and I'll go through those steps again. But if you were doing this with a neighbor right now and you both cleared your calculator and you started all over, you're going to get the same random sample. All right? All right, these are the practice problems in this section, and that's it.